Yeah, in this video, we will discuss about the connection and the organization of the registers in general register organization. This is how the organization of the general registers is getting to be showcased. That is, this is how the general registers look like in your computer system. Okay. Now, in this case, we do have 7 registers, 7 general purpose registers. That is from R1, R2, R3, R4, R5, R6, R7. A total of 7 registers. Okay. There are 2 multiplexers, multiplexer 1 and multiplexer 2. Of course, there is an ALU and there is a decoder. Try to understand the purpose of each and every entity in this organization. Okay. So now, when a general register organization is considered, then we do have some additional registers to the special purpose registers we did have in single accumulator organization. That is, in single accumulator organization, we had program counter, address register, so on, special purpose. These are the special purpose registers till output register. Okay. We discussed the purpose of each and every register. In addition to these registers, we do have all these registers. Okay. So here, the advantages, as I told you in the previous video, when we perform an operation that is A is equal to B plus C, each and every variable in this operation can be assigned to a processor's register, and the updation can be performed within those registers. And let us see, I want to perform this operation A is equal to B plus C. How it is going to be done? Before we perform the operation, we try to understand the purpose of each and every entity here. There is a register set, of course. There are total 7 registers. There are 2 multiplexers, multiplexer 1 and multiplexer 2 and a decoder. The purpose of this multiplexer is to enable one of the registers. That is, ALU, not to perform an ALU operation, I do require 2 source register. This multiplexer 1 is going to select one of the registers and send it to the ALU. This multiplexer 2 is going to enable one of the other register, which is going to act as another source register for performing the operation, and that will be sent to the ALU. Okay. And all the registers are connected to both multiplexer 1 and multiplexer 2. You can see the connection. You can clearly see this is a 3x8 multiplexer. The input connections to the multiplexer are from the 7 registers. R1 is connected, R2, R3, R4, R5, R6, R7. All these are connected here. Okay. And there is an input register also connected to this multiplexer. Okay. This is input register, let us say. Input register, let us say. This input register, it is the first input for both of the multiplexers. And multiplexers, these 2 multiplexers are having the remaining registers connected to them as the remaining inputs. Okay. So that is, all these registers, in addition to these input registers, are connected to the multiplexer 1 and multiplexer 2. Okay. Now, when you want to perform A is equal to B plus C, first you have to ensure that A is assigned to one register. Let us say here the operation will be R1 is equal to R2 plus R3. That means that A is assigned to R1, B is assigned to R2, C is assigned to R3. So the operation that is needed to be performed is R2 and R3 should get added, should get transferred to R1. Okay. Now, let us see how this is going to happen. There are selection inputs for these multiplexers. As it is a 3 into 8 multiplexer, there will be 3 selection inputs for both multiplexer, for both of these multiplexers. Okay. Selection A is going to decide which register will be enabled from here. Cell B is going to decide which register will be enabled from here. Okay. If it is 000, input register will get enabled. Let us not talk about this input register for some time. Right from 001, let us say this R1 value is 001 because this is the first register. This is second register. This is third register. This is the fourth register. This is the fifth register. This is the sixth register. This is the seventh register. So now cell A must select, second register. Yes, no? Register 2 must be selected as the first operand. Register 3 must be selected as the second operand. So the multiplexer 1 will select the first source register, that is R2. First source register is R2, second source register is R3. The first source register will be selected by multiplexer 1. Okay, so selection A inputs must be equal to 001. When it is 001, then what will get selected? R1 will get selected and will be sent to the ALU via A bus. There is a bus which sends the contents from the multiplexer to ALU. And then when it comes to the multiplexer 2, it is going to select the second source register, that is R3. Okay, so in order to select R3, what are the combination here? R3 is equal to 011. These selection B inputs must be equal to 011. Okay, when it is 011, what will happen? This is 0, it is not 001, it has to be 010 because R2 must get selected, right? It has to be 010. R2 is 010, R3 is 011. So what will be selected by this cell B? These selection B inputs should be 011 because R3 is equal to 011. Okay, so this multiplexer is going to enable R3. Once again, bigger pardon, earlier I said 001, but it has to be 010. So when 010 has been selected, R2 will get selected. When 011 gets selected, when are the inputs, then R3 will get selected. So R2 and R3 get selected and will be sent to the ALU. R2 and R3 are available in the ALU right now. Now the ALU has to perform an operation. But the ALU can perform many operations, right? ALU just not for addition. ALU can perform multiple operations. But one of the operations should be selected. That operation will be selected by this operation selection inputs. Okay, there are operation selection inputs which will decide which operation needed to be performed within the ALU. Okay, so the operational inputs must be appropriate inputs which will select addition. Okay, so by setting the appropriate operational inputs, will make ALU performing addition in between R2 and R3. Then finally, ALU is going to perform R2 and R3, the product that is available right now, that is sum of R2 and R3. Now, this must be transferred back to R1, right? In order to transfer this back to R1, we need to select this R1, one of the registers from the available general purpose registers. Okay, how do we select? For that, I'm going to use a decoder. Okay, this decoder must select the destination register. When MUX1 is selecting the source register 1 and MUX2 is selecting the source register 2 for performing the operation, this decoder is going to be used to select the destination register. So the decoder selection inputs must be 0, 0, 1, because the result must get transferred back to R1. Okay, R1's label is 0, 0, 1. So when 0, 0, 1 is the input for the decoder, then R1 will get selected, and finally the sum will get transferred. The result of the ALU operation will get transferred to R1. Okay, so this is how in the general registers, in the general register organization, the things gets very simple. The operations can be performed very flexibly and easily. If you want to perform the same operation in the single accumulator organization by using only one accumulator, this operation may take a lot of time, because accumulator should accept R1, then R2 must be added, followed by R3. Then there are a lot of stuff that has to be done by using a single, only one register. But here, all these variables can directly be assigned to these registers, and the operation will be performed, and result will be transferred back to another register. So the operations can be performed very faster than single accumulator organization. Let us have a recap. What happened here? I do have 7 general purpose registers in which any variable can be stored. These registers are additional register to the special purpose registers such as program counter and address register. Here I do have 2 multiplexers which selects 2 source registers for the operation. Multiplexer 1 is going to select first source register, in this case R2. R2, in order to select R2, multiplexer inputs, these cell A inputs should be equal to 0, 1, 0. Cell B inputs must be equal to 0, 1, 1. Cell A, cell B, selecting source register 1, source register 2. These operational inputs are going to select the operation within the ALU that is needed to be performed. And this decoder is going to decide to which register finally the contents of the output of the ALU should be transferred. Okay, so that is, this is the selection input D, which is going to decide the output register. So this cell D must be equal to 0, 0, 1. This is how the operations can be very easily performed in single accumulator organization. You can clearly see. You can clearly see. Mux A, multiplexer A selects source register 1. Cell A meaning source register 1. That is R2 gets transferred to bus A. Multiplexer B selects source register 2. That is R3 will get transferred to bus B. From bus A from bus A and from bus B, the contents will get transferred to ALU. ALU operation selector will select the operation, and that is addition that will be performed in the ALU. Okay. Decoder destination selector, that is cell D, it is going to perform. It is going to select the final register, that is the destination register, that is R1. Okay. From the output bus to the R1, the contents will get transferred. This is the output bus. It will get transferred. Okay. So this is how the operations are going to be performed in the single accumulator organization. So ALU operations are designed in this way. That is, when 0, 0, 0, 0, 0, transfer A, then here you can clearly see in this table which is for which operation.